Okay, so very welcome to this course in scientific computing for Python and Fortran for the Compute School. I'm very happy that I see so many interested in this course. We are over 44 participants currently. So there will be some minor adjustment to this course. There will be a bit less turn-ins for each module. I will come to that later. But it still will be the project assignment at the end that we have been doing before. So first, I would like to just present myself as well. So my name is Jonas Lindman. Bit of history. I have programmed computers since the 80s. So I have started when the Swedish school system introduced their ABC80 computers from Luxor. I had my sessions on Texas Instruments TI-994A, Commodore 64, Amiga, and PC. I also started at the university here in '98. I graduated as a civil engineer, actual civil engineer. So my major was kind of in construction, and after that I did a PhD in structural mechanics. After my PhD, I started work at Lunar, the Center for Scientific and Technical Computing, first as a system engineer to build grid computers for the CERN collaboration. In 2009, I became technical director for Lunar, and now I'm currently the director of Lunar, which has around 12 staff. So that's a bit about me. Kind of a scientific computing nerd. So I really like to teach and also to teach about programming scientific computing. I have done a lot of different programming languages during the years. So I started with Pascal in the early 90s. Of course, I did BASIC for my home computers before, but Object Pascal was my main language that I learned. I have been doing C++ since the 90s and forwards. Fortran since '98. Since I started in my PhD program, I started programming Fortran. I did some Java programming, but not much. And Python, I started kind of after my PhD work. So it was my opponent at my defense that introduced me to Python, and it has kind of grown on me since 2003. And it's very nice to see that Python has become one of the more popular languages in the world for programming, and specifically scientific computing as well. So I also done some. I do a lot of in my spare time creative programming. That means combining music and programming in an environment called processing. A little bit of JavaScript as well, but that is not very much. During my time here, I developed a lot of software codes. So I did mainly for structural mechanics, focused on interactivity and visualization. So I did a force-fed application, which is the top level here. Let's see if I can just my. So the top one here is the force-fed programming. It's an interactive real-time finite element code. I did a 3D frame analysis software with visualization. I developed a finite element toolbox called CalFem together with structural mechanics, an application portal, a lot of tools for Lunark. I did also a Python installation of CalFem that is still used in the structural mechanics courses that we do today. Some other scientific programs here, visualization tools for pseudo sections in 3D. I developed the Halcon with software simulating software in hardening concrete. If you're using Lunark, you probably have seen the launcher for the interactive applications. That is also something I developed. I did some things on my spare time as well. So this is a timing display that I have in the motocross club where my daughter is driving. So sometimes you have to do program outside your box as well. So back to the course. The course is divided into several modules. I will show them in Canvas later. We'll start off by going through an introduction to Python. I hope many of you already have some background in programming, but I will do the first lecture will be on introducing Python, Python language. Then we will next week go through matrix computing with Python. So similar to perhaps if you have a MATLAB background, how to do matrices and matrix computing using NumPy and Python. We will do plotting with Matplotlib. So how do you present your data in a readable way? And the many options you have there. We will go through built-in functions in the Python library. So doing file operations, I/O, different things that could come up in your scientific work. What is built into Python and how you can use that. We will do an introduction to object-oriented programming in Python. So, of course, we can't do a complete object-oriented programming course in this format here, but I will give you an introduction to object-oriented programming with a focus on how it's implemented in Python, because that is an important concept when we later go to both data processing and visualization, as well as the user interface, creating user interfaces in Qt. So then you need to know the object-oriented concepts that those are based on. Data processing and visualization will go through one step further than Matplotlib to process your data, get it into a format where you can present it in 3D, 2D, and using advanced visualization software, for example, ParaView. Then I will introduce you to user interfaces in Qt. Qt is a library which you can use in Python to create advanced user interfaces. Then we will go through Fortran, which is a very old language which still is developed and is very high performance with regards to numerical computing. I will go through the modern versions of Fortran, so I will not teach the Fortran 77 standard. So this will be Fortran 2008 and forward standard for programming Fortran. So you will see that this language is not far off from Python or C. It contains very many modern features. We will also very shortly cover how you can combine the Fortran language with Python. So integrating Fortran code into Python so that you can use it just like any other Python modules that you developed, but with still retaining the performance of the Fortran language. Of course, yeah. So for each of these modules, there will be an assignment, so which you should turn in, and those are done in Canvas as well. At the end of the course, there will be a larger assignment for you to turn in, and that assignment can be based off your PhD work, or it can be you can take one of the predefined project assignments that I have had in the course that you can use. Lectures will be Tuesdays from 13:15 to 1500, with a short break in between. So I will probably teach until 2 o'clock, and then we have a shorter break and then continue until 1500. Tutorials is on Friday. We will be 2 assistants in each workshop now because of that there are so many of you. So Carl Eriksson, which is probably here as well, he will help me out in the tutorials on Fridays. Course administration is done through Canvas, and I can see that you found Canvas and you have been able to log in, so that's good. Assignments are also turned in through Canvas. I will also try to answer the comments, and if you can send me questions in the inbox of Canvas, and I will try to answer them as quickly as possible. Course literature So here's just some suggestions of links that you can use. The material I provide will probably be sufficient for you to do the course. So most of the materials I provide is in an interactive notebook form, which you can use. I will show that later here. But if you want to dive in, there are some web-based tools that are very good, web-based material. There is also books. So unfortunately, I have written a book called Ingenjörens Guide till Python, which is unfortunately in Swedish. I'm working on the English version of that, but it covers most of the subjects in this course as well. There are some other books called Learning Python, Programming Python, and Python Scripting for Computational Science that complement this course as well. So most of you can probably learn most of the things in this course through the slides that I provide. I've also, before we start the introduction to Python, I want to give you a short introduction to Lunar as well, because I work there. And so Lunar is Center for Scientific and Technical Computing. So we provide high-performance computing resources at Lund University. We have currently a cluster called Aurora, which is 300 servers big, attached with a 4 petabyte storage system. And on this, in addition to this hardware we provide, we also provide training education. So this course is kind of part of the training and education that we provide today for you to be able to use these resources as well. So the Python knowledge that you will get in this course, you can take and use on the Lunar resources. So the Lunar systems also provide a very powerful scientific computing environment. So you can log in using a desktop, and you can have access to visualization softwares and interactive software with accelerated graphics, 300 computing nodes, and over 700 scientific software packages, including the Python environment that I'm going to show you here is also available on Lunar. So you can take your knowledge and use that resource as well. If you want more information, you can go to the Lunar website as well. And the environment, this is kind of an example of the environment you can get on Lunar. So you will, when you apply for a project at Lunar, you will no, I pressed the wrong button, sorry. A bit off here. Yeah, so this is the environment you will get on Lunar. So it provides you with a desktop, which you can access remotely. You can run your applications, disconnect, come back, and your application is still running. And you can do scientific visualization using several of the installed packages that we provide. So please keep that in mind that you can do these things in this environment as well. So now I'm going to show the Canvas page. So this is the Canvas page. You will find here general information, course information, the course material links, also the software you need to install on the different platforms. For the first part of this course, you only need Anaconda Python environment or Python environment with the NumPy and Matplotlib installed. But read through here and you can see how to use those. And then I will provide the lectures and the course materials, the links to videos, and all the necessary stuff you need for each of these modules provided here. There's also a link to the assignment that is for next week, the Python 1 assignment here. And then I will open up more and more during the course here. I will also my lectures will mostly be using something called Python notebooks. So what you can do now, if you want, you can click on the first link here, Introduction to Python. So you can follow along the lectures. You can also do interact with the lectures during the lecture. It will not be shared, but it's your own environment, and you can try out the things yourself. So I just want to. So this is the introduction to Python lecture. If you want to do interactive here, you can. There is a, if you're an English browser, which probably says connect. So if you press that button, it will allocate the Python environment that you can interact with. So Python. So Python has is a relatively young language. It was created by Guido van Rossum in 1991. And the basic idea of Python was that he wanted a language that was supported code readability and able to write large applications in a clear and logical style. So that became Python. Some of the features of Python is that it's dynamically typed. I will go through this later, but if you compare to C, C++, and Fortran, many of these languages are statically typed. That basically you have to describe the data type before you run your application. In Python, variables can switch data types during the run. So at some point, the variable A can be an integer. At a later point, it can be a floating point or a string. It can change during the run of the program. That is what dynamically typed means. It doesn't mean that Python lacks data types. It's actually very strong data types in Python, but it means that you can switch between these data types during the run. You don't have to explicitly tell what a variable should be, the kind of data type. It's when you assign a variable, the data type will be assigned. And it also has a special feature. It supports multiple programming paradigms. What that means is that you can program structural programs, procedural programs, object-oriented programs, and you can also do the more modern functional programming in one and the same language, which is quite powerful. Python 2.0 was kind of the first major revision, was released in 2000. Python 3, which we'll be teaching in this course, was introduced in 2008. And the thing is that those are not entirely backwards compatible. So Python 3 introduced several revisions of a language that are not compatible with the 2.0 versions. So you have to be careful about that. But the 2.0 version has been reached end of life, and you shouldn't develop new code in the 2.7 series of Python. You should instead go directly for new code to the latest version 3.x or 3. Something, which is the current version is actually 3.9.7. Anaconda probably uses 3.8. There are no large differences in those releases. You can also the main Python page for the language is called python.org. Here you can download the latest bleeding version of Python. You have to remember, though, that this version doesn't come with all these numerical packages. So this is a kind of plain vanilla version of Python with the basic runtime libraries available, but nothing more. If you are more, which we are probably geared into scientific computing, the better way is probably to install Anaconda Python or a similar distribution, which is a combined Python distribution which contains all the packages that you need for scientific computing. Examples here, Anaconda, and also WinPython, which is a special version for Windows only, which also contains the numerical packages you need. So the language philosophy of Python is beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex, and complex is better than complicated. And readability counts. And And one thing that you will see when you look at Python code is that it forces you to indent and write your code in a structured way within the indentation. There is no, it's very hard to write unstructured code in Python. It's kind of designed in a way that it forces you to write the code in a certain way that will be very structured. The program structure. So Python programs are a text file that contains rows of statements, which is very similar to many other languages. The difference comes when you translate a program to machine code or code that can be executed on your computer, is that Python interprets row by row and executes row by row from these text files directly. Compared to, for example, C++, Fortran, and languages like that, which translate the entire source code to machine code, a machine code executable, which can be run on your computer. So it's a bit different. Empty lines in the source code will be ignored. All the standard source code extension for a Python file is .py. Yeah, they're also called source code files. So Python source code files are they're also source code files in the same way. So this is an example of how a Python code can look like. So you can have comments with the hashtags here. So these first lines are just, it's optional. It tells which kind of Python interpreter you want to run, what kind of encoding your text file has. You can leave this out. It's just it's not necessary. The statements here, you have a for statement here that will count to 8, I think, and print them out. You can also see here something that is a bit different from other languages. There is no begin or there is no curly brackets. It's you indent your code block here that belongs to the for loop, and the actual indentation is what defines the structure of your code. So you have a colon here as well, which is the way that signals Python. Now there is a new code block, and a code block starts with indentation like this, and the print statement here is what is part of the loop. So you can try it yourself. You can press the play button here, and it will execute the code here, and you can see it will count from 0 to 8. I will go through exactly what that means a bit later here, but this is the way it works. So, for example, if you move this here, I just move the print statement outside here. This will not belong to the loop anymore because this is outside the indentation here. So this is the indentation, and this is outside the indentation. Like this, and now it works again. Most of the functionality in Python is provided using built-in functions. And Python has a very large runtime library. What that means is that it has a lot of built-in functions for providing a lot of functionality, not only providing math functions and string functions, but it actually has a lot of modules for example, downloading for internet, processing different file formats. That is built in, so you get a lot for free. One very common function is to print something out on your command line or in your notebook. You can use the print statement for that. And the function in Python starts with the function name. Then you have a parenthesis, and then you have a list of parameters that you can give to your function. So in this case here, when I run this, it will print out the string here and the number 42. So that is a typical way of function. Some functions don't have parameters. Then but you still need to provide a parenthesis for it to work. So in this case, print statement can also take no parameter, and then you will just print an empty line and go to the next line. You can have functions, and functions have will you return a value from the function, and you receive that value by assigning a variable to that from that function. So in this case, I have a absolute function here with -4, and that will return the result here, and I can assign that to the y value here and print it out later here, like that. Python also has the ability, just like MATLAB, to return multiple values from a function. In that case, you need to provide two variables with comma separation here to receive those two values. So you have to look at the documentation for the function to see if that actually what the function actually returns, so that you can receive both of them. So in this case, I have two variables I return. If I'm not interested in one of the variables, one convention is just put an underscore at that point and just ignore, not use it. But you need to, if you only do like this, you will see that it will still return, Q will contain a pair of values instead. So it's not entirely what you want. So if you want to assign two variables, you need to specify it in this format here to receive both of them in separate variables. So storing and referencing data. One fundamental feature in programming is to be able to work with data in different ways that are stored in memory or in other ways. And one thing that is very important to know is that in Python, the variable itself doesn't store the data. So the variable points to data in your computer's memory. So it's like when you leave your clothes in a restaurant, you get a ticket back, and that ticket is your way back to the data. And also the data type, when you assign a variable, the memory is allocated automatically. The data type decided during the assignment. So if you look at the code here, we have a equals to 1. That will create the variable a, and a memory is allocated for an integer value of 1. An a variable we reference that memory location. Same thing here, b here, I will assign the variable b with the value 15, and that will the b will be a reference to the integer value 15 stored in memory. If you want to create floating point variables, you have to specify a decimal point. So in this case, if I assign C 14.2, it will be a floating point variable. It will store a floating point value in memory, and C will point to a floating point value. So C can be looked upon as a floating point variable in that sense. A string variable is created just by assigning E, and you use quotes. I will get back to how you create strings in different ways later, but simple form is either double quotes or single quotes. You can use them either one of those to create strings. You can create lists. You do a square bracket, and then you just list the values in the list, and it will create a list. But what difference here, if you look at the last line here, now I use A again. And now A will point to a string in memory. And this is quite okay. You can start by having A being an integer, and then you can change A to be a string. And that is what you mean by dynamically typing. You can change data type during the run of your code. Naming a variable. So in Python, there are some rules on how you can define variables. You need to only use letters from the English alphabet. So unfortunately, we can't use any of our Swedish extra letters. It can contain numbers. you can't use no special characters except for underscores. And it can't start with a number. Variables are case sensitive, so lowercase a is not the same as uppercase a, which we have to think about later when we talk about Fortran, which is case insensitive. But Python is case sensitive. So allowed variable names are first underscore name, last underscore name, number, and I2 starts with a letter, has the number as the second one. However, the next two ones here are not okay. So it starts with a number, which doesn't work, and L has a Swedish letter L, and that we can't use that because that is not from the English alphabet.
So the difference between I2 and one var is that one var starts with a number.
Yeah, that is exactly. So that's why it's not okay to use.
Okay.
I have never had the need to use variables that start with a number myself, so it's a bit unusual, but that's the way it is. But it can start with an underscore, so that is okay. So as I said before, variables in Python always references to the underlying data. And when you assign a variable, the first thing is happening is memory is allocated for the value to be stored. And then there is a named variable reference created, the variable itself. And then those are connected, so the variable refers to the memory of the value. So if you look at the following code, I have A equals to 42, B equals to 84. What happens in memory is then you have A is a reference to the memory location here in gray. B is a reference to the 84 memory. So we have two variables pointing to two different memory locations. But what happens when we do an assignment of A equals to B? Everything happens as expected. But what happens underneath is a bit different than you probably think it is. So what happens is that A now points to the same memory locations as B, because you assigned A equals to B, which then assigns A to the same reference as them, so that they both point to the memory location of the value 84. Most of the time, this will work just like you think it will work. So there is no difference in that case. But there are certain situations you have to think about, because many other languages, when they assign things, they actually copy things over when they do the assignment. But in this case, this only references that changes. And also, if I do another one here, if I do A equals to 21, we have the several situations. So A now points to 21, a new memory location with the value 21. And 42 now is kind of orphaned. So that memory location is no longer used, and Python will automatically clean those up in the background. That's called kind of garbage collection. That will automatically be handled in the background. So you can have multiple variables pointing to the same memory locations, and the memory location will still be there until there is nothing pointing to it anymore. So then it goes away. And we can actually check this in Python with using a special function called ID, and that will return a unique identifier for your variable reference. So in this way, we can actually check what happens when we do these operations. So for example, here, if we run this code here, we do the same here. First we assign A and B two values. Then we print out the value and the ID. And we can see here in the beginning here, we have 42 and 84, and then we can see we have two unique references. They are different. Then we do A equals to B. And now we can see 84 and 84 here, same values, but you can also see that the references, the IDs are the same now. And now we create A equals to 21. And you can see we have 21, and now we have a new unique reference here. And B still contains the ID from the early assignment here. Most of the times you can do just like intuitively you assign variables in other languages. It's just, I think I will, important that you get this early on before we do a lot more, that you can see that every variable is a reference in Python. Yeah. So data types in Python. So as I said before, data types are determined when you create a new variable and assign that to a value. So in this case, this is an integer, then the variable will also be of integer type. And if we do 42.0, it will be a floating point value. So that is determined when you assign a variable. If you want to work with floating point, this could be a good idea, even if you assign a 1, assign 1.0, then there is no doubt that this is a floating point value. So I try to make that a rule when I do my codes. If a variable should be a floating point, just put a decimal point and a 0 after or something, then it becomes the right data type. Operators and expressions. So Python evaluates operators in the same way as most other languages. So you start with exponentiation. Union operations such as negating and variables is next. Then is multiplication, division, floor, and modulus, addition, subtraction, comparisons, Boolean not, and an or. So not very different from other languages. And here you can see you can use it as an advanced calculator as well. And you can also see here if the result will be a fraction, or it will actually return a floating point value. And same thing here, if you divide two integers, it will return you with the floating point result. This was actually a bit different in Python 2, which actually returned integer result divisions here in this case. There's also Boolean variables, so variables that can be either true or false. And there's a special identifier for that in Python called true or false, which you can assign a variable, and then that will become a Boolean variable. One of the most powerful data types in Python is the list. And the list can contain any other references to any type of data. So you can add anything to a list. You can even add other lists into lists. You can create an empty list by just assigning, for example, an empty bracket, pair of brackets here. That will become a list. And if you have an empty list, if you print an empty list, it will just print out an empty bracket. If you have a list with predefined values, you can just create them directly in runtime, and then you list your data, your values separated by comma signs. As the same way as the data type was determined by the data, the actual value assigned, same thing for the list. So in this case, the first 4 here will be integers, the next one will be string, then you have a floating point value here. And all of those can be combined into a list. You access the different elements in the list by using the square brackets. So in this case here, if I want to have the third element, I specify 2, and that is because all by default the lists are 0 based. So all indexes start at 0. So in this case here, number 2 is 0, 1, 2. So it should return number 6. So it was correct. You can also change values in list by assigning an index. So in this case here, you can specify, so the 5th element in the list should be changed to the string hop. And hopefully that will change the string from hey to hop. And that is very intuitive. As I said, the list starts with 0, but you can also use negative indexes, and that is really a powerful feature. So when you specify a negative index in your when you access a list, it will actually return the last item in the list. You can look at it that it wraps around in memory. So it goes back from, if you go on the left, it will go to the last item. If you go -3, it will go last 2 items. So this is actually a quite quick way to actually get the last item of a list, for example. So this will return -1 here, so it returns this one here. So it will go 0, -1, go back here and return this one here. And if you go -3, it will go -1, -2, -3. So it should return the number 4 here. And it seemed to be correct. So lists is also is this, references to data in memory. So in this case here, the list is visual here. The values is a reference to a list container, which is also allocated in memory with the gray area here. And that list container contains a lot of other references to data. So in this case here, 1, 3, 6, 4, hey, which is a string, and a floating point 1.0. So we can look here. In this case here, I assign B here a reference to the value 4 in the list. So this is 0, 1, 2, 3, 4. So that is a string here. I print out ID of B, and then I print out the value 4 of the in the list here as well. And you can see these are the same. So B now points to the same memory location as the item in the list points also to. So you see here, you can things point to the same things. Which is also, you have to think about when you, for example, if I do, now I will get back to that. So just important to think about. So in this case here, you see values here, the list points to this one, and B points to that one as well. So if I change the list here, but it points to the same location as that memory location here. And for the most part, same thing here, it works intuitively like it should be. It's also possible to define ranges of data from a list, for example. So you can use, it's very comparable to the MATLAB index notation. So in this case here, I have the values list here, and I can specify here that I want the values starting from 1, going up but not including 3. It's a bit odd range here. It comes from the fact that there is a range operator that does the same thing, that it returns you up until but not including the last item here. So in this case here, it will return positions 1 until 2. You can also do the same thing. You can have starting 1 and going to the end of the list with using the minus notation here. You can have starting from 3 going to the end of the list. Of course, you put a single colon here, that will return all the elements in the list. This will return all elements except the last 2, and so on. So it's quite powerful to kind of extract different parts of the list. Sometimes you need to query how many items there are in the list. And that is also possible to do by using the generic len function in Python. So you will see some of the concept in Python coming through used by many data types in Python. So len can be used by any data type in Python, which supports kind of storing items in a container. So len can be used to query the length of those data types. So in this case here, if I print len values, it will return the number of values I have in my list. So that should be 1, 2, 3, 4, 5, 6, 7. So seems to be correct here that this list contains 7 values. You can add values to this as well. A list is something called an object. And objects can have functions applied to them to do certain operations. So in this case here, I have my values list here, and then I call append on my values list and add a value 42 to that list. So if I run this here, you see here it added 42 here to my list. It's also possible to insert values at certain positions in the list. So in this case, I can use the insert method here to insert at position 1. So not 0 here, but here before the number 3, there should be a string squeeze. And you see here it added the squeeze here at that position. You can remove items from a list. So in this case here, I have print out my values first here in the two first lines here. And then I can say, I want to remove the string squeeze from my list. Then it will find the squeeze item in the list and remove that one. So if I run this, you see here that in this case, I have squeeze here, and after remove, it's gone. There is also another generic function called del, which you can use on any data types supporting iteration, strings, dictionaries, lists, and so on. And in this case here, I want to remove value 0 from my list. So I just provide that to my del function. And that should remove the first item. Hopefully the 1 should disappear, and we should have, it starts by 3 now instead. You can also delete entire ranges of the list here using the range notation. So we can delete and then values starting from 3 going to the end of the list. So let's see what happens if you run this one. So now we wanted to delete from 3, so 0, 1, 2, 3. So these here should be deleted. And you can see here that it seems to be correct. So it removed everything from hop until the end here. In computer science, there is a data type called stack, which is used to push things to the stack, and you can remove them using pop. And there is actually a method called pop, which actually remove an item from the list and return it. So in this case here, we have 364. I do pop. It will take the last value of the list, return that, and assign that to my variable. And the list is modified and the value is removed from the list. But it can be useful sometimes. Clearing a list. The one easy way is just to assign an empty list to the variable. And as I said before, this list here is in memory. When I do a new assignment A equals to an empty list, that list will be orphaned. There will be no longer be a variable pointing to that list, and that will be removed using garbage collection. You could have another variable B pointing to that list as well, then it will not be removed. So in this case here, A now points to an empty list. To illustrate the following statement here, I said is that I have A here equals to 4, a list with 5 items. And I do B equals to A, and then I do an empty list on A. And you can see here that B still contains the first list here, and A now contains an empty list. So as long as there is a variable pointing to a list, it will still be around. If you really want to empty the actual data in a list, there is a special method called clear that you can use on the list to actually empty the list out. And that will actually take the existing list in memory and remove the values from that list, or the references in that list. So in this case here, I have A, assign a list of 5 numbers, and I assign B to the same list. I call clear on my A list, and now you see here B is also empty. So it will actually take that list that both of them points to and empty that out. You can also, the list is actually a very powerful data structure. So you can have multiple levels of lists inside lists. So you can have list of lists. So in this case here, I have a list here consisting of 5 items, which one of them is a list in itself. So if I want to access this list, I can do A2, 0, 1, 2. This is a list, and it will print out as a single list here. If you want to access items directly in the nested list, you can just add another bracket to your reference here. So I want to access element number 2 of A and the first element of that list. So in this case, we can have A2 and 0, and that will print out the value 3 here in this case, and 4 in the other case here. So in this way, you can create 2-dimensional data structures. And here's another one here. I create a virtual spreadsheet in this case here. I create an empty list here, and then I append 10 values here to each. So I will create 4 lists here inside that list that will correspond to the rows in the spreadsheet. And this is this multiplication operator here. So if you have a list and you multiply that by a number, it will actually create a list of 10 values. So this is a shortcut of actually creating a list with 10 items in it. And you can see here, I print a spreadsheet, and I can print a length spreadsheet that will print the number of rows here in this case. And then I can access first row 0, item 5 directly here.
So it's not obvious to me why it seems almost like it repeats itself. So it would just create one row with repeated 10 empty spots. How does it know to like add a new spot in the list? Oh, append always adds a new one, right?
Yes.
Okay,
yeah. So this inner thing here will take a list of a single item, and the multiply operator will, if it's a list on the left side, it will repeat the 0 and create a list of 10 items. And that is this one here. This is the one row that has been created by this multiplication operator. You can use the same concept later on in strings. If you have an empty string or space, you can multiply an empty string by 10, and you will get a string with 10 spaces in it. So that is a way of quickly creating strings of a certain size or lists of a certain size. Okay. One thing to note, though, with lists is that if in this example here, I have a B here, that is the list 2-item list, which I add into list B, A here. And if I change B0 here to a different value, that will actually change within both of these lists. So B is not independent from A. So if you assign A here, they are connected together. So the actual memory is displays like this. You have A here, 1, 2, 5, 6, and then you have a reference to another list here. And if you modify the values in A, it will actually modify the B list as well, because everything is references in Python. If that is not what you want, if you actually want to have 2 independent lists, there is a very easy way of doing this. Is instead of assigning B here into this list, you can do a b.copy. That will make a copy of the B list and add that as a separate list in A. So in this case, when I change B0 here to -1, it will not change in this list here. So this is the way it looks like in memory. So first we have B -4, then we take a B copy here to be inserted into the A list here. We'll take a 10-minute break now and come back at 14:20, and I will continue the Python lecture. So make a short break now, 10 minutes. Okay. So we continue. So we did a list now. There is actually another very similar data type in Python called a tuple, which is it's very like a list, except it has some properties that are a bit different. So in this case, a tuple is an order data structure. That means that the data contained in tuple can't be reordered. You can't change the items in a tuple. And the difference from a list is when you create them, you surround them by parentheses instead. So the data will look something like this, 1, 2, 3. The reason for this data type is that in some certain situations, for performance purposes and also for programming purposes, it can be good to return an ordered list that is not changeable. It's very similar. So in this case here, I have a tuple called A. So if I print it out, it will just print the list and you can access it just like a list. But if you try to change it like you do with a list, for example, A0 equals to 42, Python is not very happy with me. So it says a tuple object does not support item assignment. So you can't change it. But what you can do actually, which is a bit, you can actually create a new tuple from another tuple. So in this case here, I create a new variable reference that consists of a tuple A, existing tuple A, and an empty tuple here with a single item here. You can't specify a tuple with a single item with just 2 parentheses, but that is different. That's a mathematical concept in Python. So in that case, you put a 42 comma that indicates that this is a tuple with only 1 element. But if I run this, you can see here I get another tuple back here. Actually, I create a list back here. So now I print B. That's wrong. A. Sorry. Now you see here I added 42 here at the end. But this is actually a new tuple here in this case. So I still can't change, for example, A2 equals to 0 here. If I run this, I will still get the same error here. Tuple is not assignable. So I can combine new tuples into can combine multiple tuples into a new tuple. That is doable, but you can't change existing ones. The next data type is strings, and strings is actually a bit related to the tuple data type. Compared to lists, the string will contain only letters, a sequence of letters, and strings cannot be changed. In the same way that you can't change a tuple, you can't change a list. So they are mutable, those as well. And that can sound like a restriction, but it's actually not, because it's so easy and quick to create new lists, and you can combine new strings, and you can combine strings together to new strings without changing the individual strings. So it's actually not the limitation it looks like. And Python is really good at having multiple ways of creating strings. And there's also multiple different string types that you can create in multiple different ways. So it's actually quite good at processing text in different ways. So the first string here is just doing double quotes like this. You can have single quotes like this. It's the same string data type stored in memory. They're identical. So the quotes are, of course, not stored in memory, but the text strings are stored in memory. And they print out the same. So there is no difference. If you want to have single quotes in a string, then the easiest way is just to use a double quoted string and put single quotes in the string. And the opposite is also true. So if you want to use double quotes in the string, use single quotes surrounding the string, like this. But you can also, if you really, Python does some processing of the strings by default. So you can provide special characters in the string that will be replaced. You can have, if you want, for example, to write the backslash, because backslash is the start point of a control character in the string. So if you want to have a backslash, you need to do a double backslash. If you want to have a single quote in a single quoted string, you can precede the single quote with a backslash, and that will insert a backslash quote character in the string. Same thing goes for a double quote. There is backslash n, which is a new line, backslash t, which is a tab character. All of those goes into the string. So in this case here, I have a string, and I have a backslash n here in the middle. That means that the first one here will go on the first row, and then a new line, and then the Python creator will be on the next line. Looks like this. So this will not be visible in the string output. It is a control character that is interpreted by the print statement. But sometimes you want to have a string that doesn't, that you don't want Python to interfere with the string in any way. You want perhaps to have the backslash n in the string. Then you can use something called a raw string. And raw strings are prefixed with an R. That tells Python, don't mess with this string. This is, just keep it exactly like it is. So in this case here, I have two strings that should look identical. I have backslash n in the first one, and I have backslash n in the second one. And the second one is just a normal string. So if you print those, you get, in the first item, it actually prints the exact string that we provide, because we told Python not to do any interpretation. So backslash n is actually as characters in the string here. And the second one, if you print that, it will print 2 rows, just like it should by using a normal string. Then we have another string, of course, that is called a triple quoted string. I call them for triple quoted string. Is that if you surround your string with triple quotes, control characters that you provide in your editor will actually be preserved in the string. So in this case here, I have a string here that starts here. I have a new line here. I continue to the next line here, and I have a next line here. And what Python does is it actually takes those control characters that's inside your editor in your source code, and those are contained within the string as well. So if you print this string here now, full name, it will actually print exactly as it was in the source code. So new line here, a new line there, and a new line here. And this can be very useful. For example, if you have configuration files or you have input files for your scientific codes, you can create templates in using triple quote strings with certain characters in them, so that you can write those to files easily, and you can configure them in your source code just like they should be in when they're written to file. So those are very good concepts. Lengths of strings. You get the length just by the same way we do for the lists, using the generic function len. So in this case here, I have 2 strings, and I just do len s1 here. That will print the length of the string. That function will return the string. So that this will return exactly the number of items in the string. As I said before, it's no problem to create new strings. Very easy in Python. So here I have 2 strings. I can create a third string just by adding them together. And you see here, now I get the string here that is a combination of both of them. So you see here that the string is immutable, doesn't really matter, because you can index the different characters. You can combine them to new strings very quickly. So it's actually not a big problem. You can repeat strings using the multiplication operator in this case. This is what we did with the list before. So in this case, I have a string here that I want to have an underline under, and I want that underline to be exactly the length of the text string. So what I do then, I have a string here that is just a dash, and I use the multiplication operator as many times as the S1 string is long. So this should produce a nicely underlined string here. So you see here, repeated this one as many times as the length of this string here. Very nice function. Multiplication operator is not only used in math, it can be used in many different ways. You can split strings. This is something that if you process data files, this is a very common operation that you want to split it up by the comma signs or the semicolons or something and divide it into a list of items coming into your data. So in this case, I have a string here with a sentence, and I can create a word list of that sentence using the split method. So here you can see a bit of the taste of object orientation. So string is an object, and an object has a lot of operations you can perform in it, and you can tell the string to do something. In this case, I have S here, and I want you to return or split yourself into parts, and I call the split method on this string here. And that will return you a list of the words. So now I have a list of the words in my sentence here. So this, you can see this is very, very useful feature when you read data separated with commas and stuff. You can use split to divide them up. And you can actually, in the first case, I didn't specify any parameters here. I just had empty parentheses. That means that it splits on space. But I can actually split on a comma instead, and that I provide the split character as an input to the split function. And now you can see here I have a string here that consists of numbers separated with commas, and I just do run here, and you see here it divides it up into strings, of course, but divided on the comma signs instead, and it creates a list, which you can use further on for doing further operations on.
Can you customize that and do like a comma plus space? And
yes, so you can split on anything. You can have a comma space, and it will split on that as well. But it's also possible. I mean, you don't have to spend too much time on doing the exact split command. You can later on you can do operations on each item in the list to clean them up and convert them to numbers as well. So just splitting it up in strings as a first step, and you can even do them in a single step. I will come to that later. You can also go the other way around, so you can go from lists to strings. So if I have these lists here, and I want to combine them into strings, you can use, this is a bit odd syntax. So what you do then is you create a space string here like this, and that is also an object which you can call a special method called join. So that takes the list and joins that list with spaces in the first one. And the second one here, you can join the list with comma signs, and then you can actually join a list without spacing. So if you have a sentence and you want to compress it without spaces, you can have an empty string that is there is no space in between, and it will create a string that is without a spacing in it. So if I run this here, you can see here the first one you get a normal sentence with spaces, then you have a string with the words separated by comma signs, and then it just combines them together to a single string without spaces. That's quite useful. You can search strings. So in this case, I have a really, really long string here. And what you can do is you can actually ask Python to see is certain word in the string, for example. So in this case here, I use a keyword called in, which is actually what it means. So you can say vocalia in S, that will return true if this word is inside this string here. So it should return a true if we run here, because vocalia is there. So it returns true. If I change this to V here, it returns false. So it will find the first instance of a word in a string. So that is a very simple way of checking if something is inside a string. But sometimes you need a bit more precise control over the searching. Then there is a find method that you can also use on the string. And find will search the string for a substring and return the position of that string. If it doesn't find the string, it will return -1. Otherwise, it returns the position of the string. So in the first case, it will return position. And the second here, there is a second parameter to find, which is the starting point of the search. So if I want to find several instances of the same word, I can just give it a position +1, and it will continue searching after that word. So if you run here, you see it goes to position 4. So 0, 1, 2, 3, and 4. This is the first position here, or far. Then I move to position 1 and continue here, and it should return. I don't want to count here, but the next one is here. And if I search for a word that doesn't exist in the list, it will return -1. So -1 can be, so you can use search and check for if a word exists. If it doesn't exist, it will return -1.
Why doesn't it find the first far?
Yeah.
Because there's a far at position 0, right?
Yeah, but that's uppercase. So.
Oh, right. Yeah. Okay.
Yeah. But otherwise, would correct. So it would be 0 if it would be uppercase here. Another common way we touch upon when we do the split here. In many cases, you want to kind of remove unnecessary spacing in a string or things you read from disk or something. There are methods for removing those spaces. So the first form is the strip method here. That will remove both leading and trailing spaces. So in this case, I have a lot of spacing here before. I have a spacing afterwards here. If I run this, you can see here, this is still part here, but of the S2 string is actually those trailing and leading and trailing spaces are removed. There are special versions of this that can remove right strip that will remove the leading trail, and there is a left strip that will remove the left and right part of it. So in this case here, it will remove the right part, so the trailing spaces. And the second form here, it will remove the leading spaces, so L strip here. So you have all the options to do this. So it's very common when you read from file and you want to clean up the input, you can use the strip version here. Sometimes you want to query the underlying data types of a variable. So that is also possible using the type function. So in this case, I created 4 variable references with different data types, and then you can print them out here and see what they are. So here you can see that there are class, int, float, bool, string. So you see there are strongly typed data types built into Python. It's not like there are anything. There are distinct data types that you can query for. The next important data type that also extremely powerful is the dictionary. And dictionaries are a container that stores values in pairs. So you have a key which you can access the value with, and you have a value associated with that key. And dictionaries are defined similar to a list. So instead of a square bracket, you use the curly brackets to define an empty dictionary. You can also define dictionaries with predefined values, and then you have to list them with first a key, then a colon, and then the value. The value doesn't have to be strings. In this case, it can be anything. The key can also be anything. You have to have the same data type for all the keys, but you need to kind of specify them in pairs in this way in the list. So in this case, if I print them out, you can see here I have a dictionary that consists of peta, that is the key, and then have a value, key, value, key, value. And the point with a dictionary is that it's very quick to find items in a dictionary depending on the key, because it's stored in a tree structure. So it's an efficient data type for searching and finding things quickly. If you have a list of items, you have to kind of do a loop and check for each, and that is not very efficient. By having a dictionary, you can find the values more quickly using the key. You can access the values just like a list, but instead of an index, you give the actual key as the access to the value. So in this case, I print the value here, and I specify the key David, and it should print out a number that is associated with David. Same thing with Petra here. So you see it returned the values associated with those keys. So what happens if you want to add things to the dictionary, it's also very easy. It's also very similar to what you do with lists. So in this case here, you do values, and then I create a new key here, Peter, and I just assign a new number here. And you see here that Peter will have a new value added to here. Actually, it should be perhaps a string here because the other ones are strings as well, like that. If there is already a value at that key, that will be overwritten. If you want to find values in the dictionary, you can use the in operator as well, just like you did with a string. So you can do print Petra in index, that will return true if Petra is part of the index. If Buster is part of the index, it will also return false in this case because it's not part of the dictionary here. And these operations are really fast, so it will find items very fast in a large index. Just with the list, it's also possible to obtain the length of a dictionary using the len function again. So you can see here there are certain functions in Python that are repeated or generic that you can use for multiple data types. So in this case here, value should be 4, and I think we had 4 value 1, 2, 3, 4 keys. This will return a number of key value pairs in the dictionary. Adding values, we already used that one, so that's a nice thing with all the data types in Python is that you can combine it in multiple ways. So you can actually nest dictionaries as well. You can have dictionaries and dictionaries. You can have dictionaries that contain lists. You can have lists that contain dictionaries. So you can create really powerful data structure in a really easy way and make them searchable in different ways. So here I have a bit more complicated data structure here. So this is could be a configuration file or something. Here we have config starts a dictionary. First key is general, and in this I create another sub-dictionary called with username and temp path. I have a key called constants that contain another dictionary with these 2 values here, or key pairs. So this is a upper level dictionary, and these are sub-dictionaries inside that dictionary. And then you can see here that I have a key here, values here, that contains a list. So just by combining these, I can create really powerful data structure, and they're really easy to access. So for example, if I want to have get the username in the general section here, I can just do config general username. And you see also I can access values, and then I can specify here that I want the second item of the list that is stored inside the values dictionary inside item section. That is really a nice way you can combine dictionaries and lists into a more powerful data structure. And a general rule I want to kind of convey to you with Python programming is that instead of inventing all your data structure yourself, try to combine and use the data structure that are built into Python. They are really powerful, and they are often implemented very efficiently. So you have most of these are implemented in C. So the searching stuff is C-based. So it's very quickly to find things in the dictionaries, and because they use C implementations of the search routines. I think we skipped. There are some tasks here so you can try out yourself here, but I'm a bit stressed on time, so I leave these up to you as a reader to do these tasks. I want to cover loops and conditional states before I end today. So now we have gone through all the data types. So now we need to kind of be able to repeat things. We need to structure our code in blocks, repeat blocks. So now we have to look at how we structure the code. As I said before, blocks that functions and loops, the code associated to those are defined by code blocks. And the code block in Python is an indented section that starts with a colon. So for the loops session here, this loop here needs a statement to which it should loop. And that statement is defined by a code block here. It starts with a colon up here. And then you have an indented section here with the print statement here. So this print statement belongs to the for loop. This print statement is outside the loop, and it will execute it after the loop. So if I run this, you can see here that it will print out to 4, and then it will print A here, which is this one here. And then you see here, this does not belong to the code block. So if I can move this up here and put this inside the code block here and run it. And now you see here that A now is part of the code block here that is belongs to the loop. So it will print A after each number here as well. So this is the indentation in Python is extremely important. I usually set my editor to not use tab, but use spaces instead of tabs. And I set the tab to 4 characters. And you have to be, it's very important that you set the editor up correctly and are consistent when you do the indentation. Because if you have different indentation spaces here, Python will also not be very happy. So if I indent a bit unevenly here and I try to run this, Python gets mad at me. It says unindent does not match any outer indentation level. So it doesn't know what this print statement belongs to because it's not indented correctly. If I just move it one space like this, run it again, it works. So indentation is important and has to be consistent. Loops. So this is one of the important parts of any programming language. They're able to, the ability to repeat certain blocks of code in different ways. So the first type of loop is the for loop, and it can loop of any data structure that has item or that contains data, or it's called iterable. So if we want to repeat something 10 times, we can do for I in range 10. So range is a function that a special function that returns a iterable list, you can say, that it can loop over. So I will go from 0 up until 9. So it will not include 10. But that was the thing I told you about the range specifier as well, that they are also using the same syntax as the range function. In this case, it will loop from 0 to 9, which is correct. You can also, in the range statement, say that it should start at some point. So 5, it will start at 5 and go to 10 because I increased the endpoint to 11. And then you can also specify a step length here. So the third parameter here is the step. And you see it goes 5, 8, 11, 14, 17, 20. So these loop statements are when you need to have an index. So if you have data structure that you want to access with an index with a number, you can use the for with an I and a range. But in many cases in Python, you never have to do loop using index. You can loop directly on a list, and you can get the item directly from the list using a loop statement as well. So in this case, I have a values list here with some items in it, and you can do for value in values. And in this case, it will loop over each value and in the values list, and value here will be, first it will be 1, and then it will be 3 for every loop iteration. So now you don't have to have an index variable to access the data. It will actually, value will be assigned a reference to the first item, the second item, third item, and so on. And then you can process and do stuff in that loop on the value instead.
And by doing that, you've created a variable called value?
Yes. But that value will, for the first iteration, it will point to this number 1. And the next iteration, it will have a reference to number 3. So that will be the kind of actual value in the list. So then you have to, in other case, you have to do for E and range, and then you use I to access the value in the values list using an index. In this case, you can skip that and go. You can get the value directly here. And that works for both dictionaries, lists, and strings, and so on. So you can use the same kind of idea in most data types containing multiple items. So, and this is the way. If you have data structure like this, and you need to kind of access the index operator, you can of course use the range statement as well. And then you can use the I to access different data, the data of different arrays at the same time. So in this way, you can do it using the kind of normal way you do it in other languages. But there are ways of doing this even more efficiently. So instead of using index operator, if you want to loop over multiple values and still have an index operator, you can use the enumerate function. And in this case, it will provide you an additional index operator that you can use for accessing other things, but you don't have to use the range, and you can get the value directly as well. So in this case, I will be the position in this array here. So you get 0, 1, 2, 3, 4 if you use the enumerate instead. It's also possible to iterate without indexes over 2 lists at the same time. So for example, I have X positions here, I have Y positions here, and I want to loop over them. So I get the first 2, the second 2, and so on. Then I can use a function called zip. And zip will kind of combine these 2 lists and return the first 2 values of each of these in the list. So you can see here, it prints out X and Y is first 50, 50, and the second, and so on. So this is a way of looping through multiple lists at the same time. And you can actually see the structure here. So when you do the zip of 2 lists, it will actually combine into pairs with tuples here in them. So that's the way so this will assign the tuples to X and Y in the outer loop here. So zip is not magical, it's just that it pairs together and creates a new list of pairs instead. If you have nested lists, for example, lists within lists, you can have nested loops here. So then you have to do indentation in 2 parts here. So you loop over the points here. So the points is these lists here. These are the points. So the outer list is going on the outside here. So P in points, this is those pairs. And then you have for chord in P. So P will be referenced this one here, and chord will be the actual coordinate values here, and I print them out here. So you see here you can nest loops as well. So this part here belongs to the outer for loop here. This belongs to the inner for loop here. So indentation is important. You can iterate over dictionary as well. Then you have to use, there are different ways of doing it. One simple way is using a method called items on the dictionary. That will return a pair of key value from the dictionaries which you can directly use. So if I loop over this one here, you can see here that it will key will be assigned the key, and the value will be assigned here, and it will loop over each item in the dictionary. There is also a keys method that will return you the key in the dictionary, and then you can use the key to access the dictionary and print that out as well. So it produces the same result. If you're only interested in the values and not in the keys, you can use the values method here, and that will print out only the values in the dictionary. There is also, you can also iterate using the while statement. So the while statement is repeats a certain block if a condition is true. So in this case, I do a sum here, and I iterate until a certain condition is applied, and then it will exit. So if I run this here, you can see here that it outputs a lot of here, and if the error is a certain point, it will exit. So that is very common that construct is available in most other languages as well. Conditional statements, if you want to check if certain conditions apply, you also use the indented code block to achieve this. So we have the if statement is probably the simplest conditional statement. So if a certain condition is true, execute this code block. So you see here, it's systematic. You start with a colon, and after a colon, there is always an indented code block. That is a rule. So every time you see a colon, it has to be an indentation on the next row. Otherwise, it fails. Then you can have else. So you can have if, and then you have if this is true, this code block is executed. Otherwise, you have else colon. You'll see there is a colon here again, and then the next indented code block. So these two here, if else, are in the same indentation level. The branches of the if statements are on separate indented code blocks. Then you can have multiple conditions here. So if this is true, then you do this. Else, if this is true here, execute this code statement, this code statement, this code statement, and then you have final else here. If nothing else is fulfilled, execute that one. You can nest if statements as well. So you have here if, and then you print here, and then you have an if statement here. So this block here is only, if statement is only executed if this first condition is not fulfilled. And then you have this underlying here that this entire thing here is a code block. You can control loop iterations as well. So for example, if you have a loop that loops over 20 items here, there are two ways that you can exit the loop. So you can do break, that will exit the for loop and continue after the loop. You have a continue statement that will go to the next iteration of the loop. So that will go back and continue to the next iteration. Yeah.
Like I didn't understand the difference between the last two, like else if and elif. Like
so else elif it so if this is true or not true, then it will do this one here, and if this is fulfilled, it will execute this one.
Okay.
So you can also do else space if and then colon. So this is a short form of actually doing else if.
Okay.
So it's just a shorter form of doing. If you have multiple conditions you want to test, you can do that. And this one is if none of these are true, it will do this last else statement.
So compared to the next one, like to the one below, this one, like
this one here is if this statement is not true, it will go to this code block here, which is if else if. So this one will only execute if this is false.
What happens if you replace elif with if?
This one here.
Yeah.
Then
or any of the other ones.
Then it will actually check this one and check this one. So elif, this one will be only compared if this one is false.
Ah, right. Okay.
So if you do this, both comparison will be done. So both of them are correct. So this is also correct. And this is correct. But they have different meanings. Okay. I think we have to finish up here. The entire lecture here is available, so you can continue on here. I will continue with this on the next lecture. And there are assignments that we will be working on the tutorial on Friday. So I have to end here now because I have another meeting here afterwards. So, but feel free, the material is available. You can continue on if you want, and then I continue the next lecture on next Tuesday. Okay, thank you very much for coming today.